Today we're going to talk about polynomial and synthetic division. We're going to start by talking about polynomial long division. You do polynomial long division very similar to the way that you do regular arithmetic long division. The big polynomial you're dividing into will go under the division symbol, and what you're dividing by will go outside of the division symbol. So for example, if we wanted to take the polynomial x to the fourth plus 5x to the third plus 6x squared minus x minus 2, and we wanted to factor that using long division, so we're going to divide by x plus 2. The big polynomial we're dividing into goes under the division symbol, and what we're dividing by goes on the outside. Now make sure all of your polynomials are in descending order, biggest power of x down to smallest for both of these. So then we look at this first term, and we look at this first term. X times what gives you x to the fourth? And that's x cubed, so we put an x cubed up here. X cubed times x gives us x to the fourth. X cubed times 2 gives us 2x cubed. So we multiply this to both of these terms here. And just like in regular long division, once you've done that, now we're going to subtract completely. So we'll do x to the fourth minus x to the fourth. That's going to cancel. That should always happen. That's how you pick this value here. And then 5x cubed minus 2x cubed gives us 3x cubed. And then bring the next term down. Now x times what gives us 3x to the third? 3x squared. So then we multiply this 3x squared to both of these terms. 3x squared times x gives us 3x cubed. 3x squared times 2 gives us 6x squared. And we subtract completely. 3x cubed minus 3x cubed is going to cancel. 6x squared minus 6x squared is going to cancel. And so we're left with nothing. So instead of bringing the next term down, we'll actually bring the next two terms down. Now x times what gives us negative x? That would be negative 1. Distribute the negative 1 to both of these. Negative 1 times x is negative x. Negative 1 times 2 is negative 2. Subtract completely, and we're left with nothing. There's no remainder here. So if we were going to factor this, we know that x plus 2 goes into it, and it would factor into x plus 2 times x cubed plus 3x squared minus 1. Let's do it again. Now we're going to divide x cubed plus 4x squared minus 3x minus 12 by x minus 3. So what we're dividing into goes under the division symbol. What we're dividing by goes on the outside. And we work our way outside in. So x times what gives us x cubed? X squared. Distribute that x squared to both, and we get x cubed, and then x squared times negative 3 is negative 3x squared. Subtract completely. X cubed minus x cubed cancels. But now we're doing 4x squared minus negative 3x squared. Subtracting a negative becomes a positive, so we get 7x squared. Bring down the next term. X times what gives us 7x squared? That's 7x. 7x times x is 7x squared. 7x times negative 3 gives us negative 21x. And now we will subtract completely. 7x squared minus 7x squared cancels. Negative 3x minus negative 21x becomes negative 3x plus 21x, which is 18x. Bring down the next term. X times what gives us 18x? That's 18. 18 times x is 18x. 18 times negative 3 gives us negative 54. Subtract completely. 18x minus 18x cancels. Negative 12 minus negative 54 becomes a 42. So that's our remainder. Now, ordinarily back in long division, you wrote a big R 42, but we don't write it that way anymore. So the way we write our remainder is we'll say it's x squared plus 7x plus 18, and then that remainder, 42, we'll put it over what we divided by, that x minus 3. And that's how you write a remainder. You put the remainder over what you were dividing by. Okay, let's do another one. Now, very important with long division. Every x needs to be accounted for, and they need to be in descending order. So we're going to take x to the fifth minus 13x to the fourth minus 120x plus 80. Notice we're missing an x cubed term and an x squared term. So when we put that under the long division symbol, we need 0x cubed and 0x squared. X to the 5, 4, 3, 2, 1, none. Every x needs to be accounted for. Go through the same process. X times what is x to the fifth? That's x to the fourth. Distribute x to the fourth to both of those and subtract completely. Remember here the x to the fifth will cancel. Negative 13x to the fourth minus 3x to the fourth is negative 16x to the fourth. Bring that next term down. X times what gives us negative 16x to the fourth. That's negative 16x cubed. Distribute the negative 16x to both of those, and then we'll subtract completely. The negative 16x to the fourth minus 16x to the fourth will cancel. 0 minus negative 48 becomes a positive 48x cubed. Bring down the next term. X times what gives us 48x cubed? 48x squared. Distribute the 48x to both of these and subtract completely. The 48x cubes will cancel. 0 minus 144 gives us negative 144x squared. X times what gives us negative 144x squared? Bring down the next term. X times what gives us negative 144x squared? That's negative 144x. Distribute the negative 144 to both of these and subtract completely. Negative 120 minus negative 432 becomes a positive 312. Bring down the next term. X times what gives us 312x? That's 312. Distribute completely, subtract completely, and we're left with a remainder of negative 856. There's a couple different ways that you can write once you've divided two polynomials to write your answer. So we can say, all right, x to the fifth minus 13x to the fourth minus 120x plus 80 over or divided by x plus 3 gives us x to the fourth minus 16x cubed plus 48x squared minus 144x plus 312. And then remember how we write that remainder, minus 856 over x plus 3. Or we can actually write it in factored form and say x to the fifth minus 13x to the fourth minus 120x plus 80 equals x to the third times all of this. Now, why do we write the remainder over the x plus 3? Because when we distribute this x plus 3 and we multiply everybody in here by that x plus 3, when we multiply the x plus 3 here, the x plus 3's will go away and we're just left with that negative 856, which is what our remainder was. So that's polynomial long division. Now we're going to talk about polynomial synthetic division. Synthetic division only works if you're taking a polynomial function and you're dividing it by x minus k, x minus a number. There cannot be a number in front of x. There can't be a power to x. It has to just be x plus or minus a number. So the process is you take each of these coefficients, and like with long division, every x needs to be accounted for. So we take every single one of these coefficients and we line them up in order across the top. And then we draw this big kind of L-shaped, box that in. And then we're dividing by x minus k. So what we're subtracting here will go out here. So they're opposite, right? If you're subtracting 3, you'd put a 3 here. If you were adding 3, you'd put a negative 3 here. And the algorithm goes add vertically, multiply diagonally. So you're going to start by adding vertically. There's nothing to add here, so the a sub n, or the leading coefficient, drops. Then you take this k and multiply it and move it over here. So a sub n times k. Add these two values together, add vertically, and then multiply k diagonally. Add vertically, multiply diagonally. Add vertically, multiply diagonally. So this will make a lot more sense once we go through an example. We're actually going to repeat the exact same answer, the question that we just did. So when we used the long division and we divided x to the fifth minus 13x to the fourth minus 120x plus 80 by x plus 3, this is what we got. Since this is just x by itself with no number out front and no exponent, we can use synthetic division. So we'll set up our synthetic division. All the coefficients of all the x terms need to go inside across the top. Every x needs to be accounted for, so 1x to the fifth, negative 13x to the fourth, no x cubes, no x squareds, negative 120x, and then no x's, there's 80. And then what you're dividing by, x plus 3, remember it's the opposite, so we're adding 3, so minus 3 is going to go out here. And then we add vertically, 1 plus nothing is 1, and we multiply diagonally. Negative 3 times 1 gives us negative 3. Add vertically, that gives us negative 16. Multiply diagonally, that gives us 48. Add vertically, 48. Multiply diagonally, negative 144. Add vertically, 0 plus negative 144 is negative 144. Multiply diagonally, negative 3 times negative 144 is 432. Add vertically, 312. Multiply diagonally, negative 936. And add vertically, negative 856. Now, what you get down here are all the coefficients in front of the x starting 1 power less. So this power was 5, so we start 1 power less. This is how many x to the 4th, x cubed, x squared, x's, numbers, and then this will be your remainder. So we have 1x to the 4th, negative 16x cubed, 48x squared, negative 144x, plus 312, minus that remainder 856 over the x plus 3. So you end up getting the exact same answer. Let's do it again. Let's use synthetic division to divide x to the 4th plus 5x cubed plus 6x squared minus x minus 2 by x plus 2. All the coefficients, 4, 3, 2, 1, 0, need to be accounted for, and they go across the top. 1, 5, 6, negative 1, negative 2. And then x minus k, the minus k goes here, so adding means you're subtracting a negative, so that's a negative 2. They're the opposite. Add vertically, multiply diagonally. Add vertically, multiply diagonally. Add vertically, multiply diagonally. Add vertically, multiply diagonally, and then add vertically. So remember, this is starting 1 less, so this was the exponent 4, so this is our x to the 3rd, x squared, x's, no x's, and then this would be our remainder, but in this case we don't have a remainder. So when we take x to the 4th plus 5x cubed plus 6x squared minus x minus 2 and divide it by x plus 2, we end up with 1x cubed plus 3x squared plus 0 x's, which we don't need to list, minus 1. No remainder, so we don't need to include that. Couple theorems that come from polynomial and synthetic long division. The first one is the remainder theorem, and this is really neat. If a polynomial f of x is divided by x minus k, then whatever you get for a remainder is actually your function evaluated at that k. So for example, let's evaluate f at 1/2 for 4x cubed minus 13x plus 10, but we'll use the remainder theorem. So note, if we're going to find f of 1/2, that means that we're taking this polynomial and we're dividing it by x minus 1/2. So we can do this synthetically. All the coefficients, 4 to x to the 3rd, no x squareds, negative 13x's, and then plus 10. All the coefficients go up here, and that 1/2 goes out here. Add vertically, so the 4 carries down, multiply diagonally. Half of 4 is 2. Add vertically, multiply diagonally. Half of 2 is 1. Add vertically, we get negative 12, and half of negative 12 is 6. Multiply diagonally. And then add vertically, 10 plus negative 6 gives us 4. So without actually taking 1/2 cubed times 4 minus 13 times 1/2 plus 10, the remainder theorem tells us that f at 1/2 is equal to 4. Feel free to use your calculator or do that arithmetic by hand to check that that actually is true. One more theorem that goes along with this is the factor theorem. If you get a remainder of 0, then f of k would be 0. That means that x minus k is a factor. So let's show that x plus 2 is a factor of 2x cubed plus x squared minus 5x plus 2. That means if I divided this polynomial by x plus 2, I should have a remainder of 0. So we'll set up our synthetic division. This is x plus 2, so we put a minus 2 out here and all the coefficients. And again, add vertically, multiply diagonally, add vertically, multiply diagonally, add vertically, multiply diagonally, and add vertically. So it turns out the remainder is 0, so that means that x plus 2 is a factor. By the remainder theorem, since this is 0, this means f evaluated at negative 2 is 0. That means that negative 2 is a 0, and we talked before about how that means that x minus negative 2, or x plus 2, is in fact a factor. That's it for now. See you next time.